Hello. Okay, let's start our today's session. Is my voice clear? Am I audible?
Yes, you're audible.
Okay, thank you. Uh, Assalamu alaikum, everyone. Welcome to today's session on data engineering using AWS Cloud. Our speaker for the session is Huzefa Khan, data engineer and cloud expert with over 8 years of experience in the industry. He specializes in AWS and he worked as a data engineer in several well-known organizations, including Affinity, Temples, and many others. We are excited to learn from his experience and gain real-world insights into how data engineering works in cloud environments. Let's give a warm welcome to Huzefa Khan. Thanks for joining us today. Now I would like to invite Huzefa Khan to deliver today's session.
Okay, thank you, Zephyr. So let's start the today's session. Let me share my screen. So Hassan, you raise hand. It's any question or it's
Hassan Ali, is there any question?
okay? Okay, let's move forward. So first of all, Ali Huzefa has already introduced my background and all this stuff. So today's session we will firstly go through all the data engineering background, what exactly what's going on in the data engineering sides and what's tool and technology, what are the main stack and what are the building blocks of the data engineering. So then we basically move to the our interactive sessions, like lab sessions, that I show the different tools and technologies on the AWS platform, the AWS console, where we basically using different pipelines we create and different processing job we create. We see the workflow and all this stuff. So before moving forward, so I will first of all get the idea, like most of you are belongs to any industry or you all are the student or what actually your background. So one of some of your guys are working in the industry, so can I get the idea?
Most of us from
Sorry. Hello, is that
Uh,
audible?
yes, yes, Zephyr, you are audible. सैफा भाई यहाँ पे मेजॉरिटी स्टूडेंट्स जो हैं वो सॉफ्टवेयर कंप्यूटर साइंस और आईटी से ही हैं और कुछ बिजनेस वाली साइड से भी हैं बिजनेस एनालिटिक्स वगैरह साइड से
Okay, all right. So mostly you are all the
Most of
student.
our university students.
Okay, great. Okay, let's move forward with the data engineering side. So just hold on. Okay, so data engineering using the AWS. So basically, you all know there's a two options whenever you are working on any field, either the software or the data side or anything. These are two systems. One is the cloud and one is the on-prem system. So most of the companies are moving nowadays, they are moving on the cloud. There is a specific reason for it. And a lot of companies that are still working on the on-prem system. The on-prem system is like servers, they set up their own servers, they have the operational overhead, they have the other cost they are bearing for all the data infrastructure and all this stuff. So you in your study, you basically go through the process like a waterfall process that basically follow in the software development life cycle, right? So whenever the software develop, so basically there's a different set of stages that you have to follow whenever you develop a software, right? So same thing is in the data engineering side as well. So in the data engineering side, we have the different mechanism or different framework you have to follow. There's one is the name is the CRISP-TM model and the TDSP model and KDT process. So that basically these processes are basically created by the industry that follow the standard of the industry of the data products. So this name is a KCM. In the KCM, we have the different stages. What are the stages that it start from the business understanding? Whenever you are basically starting any problem statement that is in the data engineering domain, it start from the business understanding. Any business, either it's a real estate business, either it's a fintech business, either it's a telco business, any business, before jumping to any product, developing or um, like a, um, like managing any kind of data product or developing architecting, so you have to go through their business understanding first. So in the business understanding, what they do, we understand their business, what are their core model, what are their core and business rules, and then we basically they're the different industries that follow the different rule set or different SOPs they follow. Let's suppose in the healthcare, we are different healthcare standard we must have to follow. So that's why the business understanding is a must important to understand or move forward any data product, any pipelines, any sort of that data related thing. So that's the first step. So, and the next step is a data understanding. You understand the data, then you basically all the aspects, what are their name and what logic behind this column, what actually it is telling about, right? And then is basically the data preparations, and it's basically you create a pipelines or you prepare the data and all this stuff, and then basically the modeling you process the data, you create a pipelines, you add different checks, and then evaluation is basically belongs to the data quality and a lot of the stuff. And then basically the at the end there's a deployment. Deployment is like you deploy the model, that is a schedule on the time and all this stuff, right? So this is a KCM model, that is iterative model. From any step you can move from the starting point, the business understanding, because sometimes you understand the different thinking and some stages when you move. So basically you identify, okay, these are the new things for us. First of all, we have to get the understanding how it's belong to the business, right? So that's the main model. So same thing is basically the KDD process. It's also the another process like a waterfall. This is another process that is used in the industry in the data products. That is a KDD process. So same thing here, the data warehouse, then data targets, then process data, then data transformations, then pattern, then knowledge, right? So you have to understand, you can learn more about this on the web, and there is another process, the name in the TDSP, that's created by the Microsoft. So that's the basically the core of the data engineering. You follow these model and all this stuff, right? So first of all, like whenever you get any problem statement that is related to the data, so basically there is some sort of the motivation behind it, right? So let's suppose you need any sort of the data pipelines you required for, that is your the modification to build the data products. There's any analysis you want to create, behind this analysis there's a data pipeline exists and any dashboard. So you want to join different type of sources data, so this is also motivations, like you want to do and slice and dice the all dimensional data with different dimension that is coming from the different sources. So that is the motivation, that is a use case basically. So then you basically start building the products around it, right? So these are the integration processes different. In the first phases you have the use cases, in the second phases you have the build the things. In the building phase you basically requirement specification. First of all you get the requirement specification. So requirement specification is not the easy. In the data you must have the different sort of the requirement, like what are your different data sources, how much data you are getting, and what kind of data you are getting, is a structure or unstructured, or what's your interval of the data, like frequency of the data, granularity of the data, right? So and then you how you basically access this data, how the system access the data, how the end user access the data, and how what's the main key transformations you needed in the pipelining stuff. That is come in the development phase, the build phase, right? And then you basically have the validation and test, the quality control checks are implemented same as the software model. So then you validate the data and all this stuff. Then basically then you visualize the data, you provide the data to the end users. And this is second phase. In the build phase all these things are coming, and there's a third phase is the operational phase. So when you basically develop the data, develop the any pipelines, any use case, any data product. So when you are moving to the next step to operationalize these things, so you basically set the SLAs, like what actually how you basically where you want to run this pipelines, which frequency you want to run. You have to set the schedule workflow, and you set the monitor its the job is properly running on each day, on each hours. It's depend on your frequency, and you monitor it. There's a different tools that monitor your jobs and all these things. And then when the problems comes, then there's a troubleshooting mechanism you have to implement, or a lot of tools that providing these mechanism. So that's a story behind the data products, like how we are developing any kind of data product in the industry. So most of the industry that follow the structures, and most of the time, because we are working in the firefighting mode, so we can escape a lot of phases, like we are not properly set the monitoring tools in the pipelining stuff. So we lose the SLAs, and but the big organizations, all the steps must follow, right? So you can ask the questions if any one of you are unclear any point, so you can ask the questions, right? So moving forward, but our main goal is basically focusing on the AWS side. So I'm just moving from these slides very quickly because a lot of things are on the AWS side is pending. So I want to focus on that side. So other than that, I already cleared the things, why the industries are moving on the cloud. The main three things: the infrastructure management issues, the scalability issues, and the multiple tools. So when you are basically developing any kind of data product, data pipelines, or any kind of data related thing, so there's two challenge come. Either we are moving on the on-prem or moving on the cloud. So why cloud adoption is too much? Because there is a lot of infrastructure management issue when you're building the product on your own server. right? Scalability issue when you scale your system. So there's a lot of overhead or a lot of scalability you have to face, and the multiple tools. So basically on the open source, when you are developing the things on the on-prem, so mostly we follow the open source tool technologies. So none of any tool are here that basically fulfill over all the end-to-end data product, like end-to-end pipeline or end-to-end results, like the processing and the preparation, the processing and cleaning and quality controls, the validations, and then deployment and monitoring. So none of single tool can do this. So that's the main issues we are basically facing in the nowadays. That's move the industry to the cloud side. So, why customer or modernize their ETL, manage ETL applications? So basically, when you're moving on the cloud, so you are basically more focusing on your product side. You're not focusing on the infrastructure side. So that's a big benefit of this. So integrate with other cloud are seamlessly at a low cost, seamlessly at a low cost. So basically, when you're on the cloud, so integration are so easy with other cloud or other products or services. So pre-priority tools and the cost basis, so break free from the pre-priority tools and the cost base. So basically such a tools that basically are not free, so you can easily get rid of these tools. So SLAs improve business agility and save costs for paying what you use, right? So whenever you set up the on-prem system, so you are paying like it's a one-time cost, but you're paying even that thing that you're not using. Let's suppose there's a machine that only validates the system. So not when you are basically when your job is not running, at that time you're also using that, you're also costing the machines overhead, like electricity and a lot of other things as well. So that's the main thing to moving on the cloud side. So okay, so when we are basically come on the any of the uh, product development or any of the data engineering sides, so these are different phases of the data engineering, right? First of all, the data sources. Most of the data engineers are working with the data sources. A lot of data sources you are when you're working on the real world project. So you're not look the data that is coming on the single data source. So you must uh, like connect the system with the multiple data sources. Sometime it's coming from the relation database, sometime it's coming from the API, sometime files, and sometime some IoT devices data is coming. So these all are the stages of the data engineering product, data engineering pipeline. So these are data sources. Then we have the ingestion layer. Ingestion, sorry, ingestion layer, we have the different connectors are there, right? And we basically connect the different data sources. There is none of single connector can be used from all type of data sources. So you must use some sort of the tool, like this tool is basically for the logging file, this tool is for the databases, relation databases side and all this stuff. Then there's a storage and warehousing stuff come, sorry, in the storage and warehousing, there is a part of the transformation as well. Before transformations, we are basically sorry before storage and warehousing, we have the transformation layer where we basically transform our data. Then we have the storage and warehousing stuff, and at the end we are basically the serving, where basically the end user are using your data. So the same thing are there in the serving and the publications side. So moving forward, this is the same thing, the data sources, the data integration, these are the modern data stacks things. So in the data sources side, a lot of data sources nowadays you can, when you're working with the any kind of industry, so you are experiencing the different kind of the data sources. Some of the data sources are the well-known, some are the new data sources, the third-party APIs or third-party tools that are come in nowadays, or different kind of databases are coming, um, are there. You have to integrate your system with a bunch of data sources. So some event-based systems are there. Yes, Abdullah, you have any question?
I have a question. Can you please differ ETL and ELT? Uh,
Yeah, sure, sure. So ETL basically the extract, transform, and load, right? So ELT is extract, load, and transform. These are two different things. There's a big difference there. So when you are basically working in the data warehouse system, so most of the companies are following E, sorry, the ETL and sorry, ETL system, and the second one is, sorry, just give me a minute. Yeah, ELT. So in the uh, let me write it here. There's a comment somewhere. Okay, just hold on. Okay, so in the ETL system, first of all, you extract the data and then basically transform the data and then you load the data, right? So in the ELT system, you extract the data, you load the data, then at the end you basically transform the data, right? These are two different mechanism. So let's suppose when you are building the data warehouse, most of the time you use ELT mechanism. So ELT mechanism, you load all the data as it is that is coming from the source system, you push in any kind of database, like the warehouse system that you're using. So the data warehouse, let's suppose you are using the Redshift, you're using the Postgres, you're using any kind of data warehouse system. So data warehouse is a relational system, right? So they follow the strategy of ELT. They load all the data as it is from the source, and then they basically do the transformations in their warehouse system. That is a ELT process. Or ETL process is basically use the extract, transform, and load. So in the ETL process, you first extract the data, and then before loading in the warehouse or in the data lake or lake house, you basically transform it, then you load it. So that's two different strategy. So why we are using, what's the need, like if the next question come, what's the need of the ELT and ETL? So let's suppose your data sources are not too much, your the data is coming from the relational databases, right? So then most of the time in this kind of pipelines, you follow the ELT process. So you just load all the relation database things as it is in the warehouse. That is the different layer. The layer is called raw layer. Sorry. And then you basically load it, you when you load all the data, then you basically do the transformations, right? So that's the ELT process. So in the ETL, in case of the lake house or data lake, so you follow the ETL processes, the extract, the transform, you transform the data. In case of you have the lot of data sources and you have to join the system, or a lot of huge data is coming, so in that cases you follow the ETL process. I think your answer is clear now.
sure, sure. It's mean ETL is best because we can do a lot of tasks like batch
No,
processing
no,
in ETL or
that's
ELT.
Yeah, that's not a case like in case of this is best. It's depend on the use case, right? So before deep dive into the any ETL or ELT process, you first full understand the requirement, what actually its needs. So based on their requirement, based on their needs, so then you decided to move on the ELT or ETLs. So in the ETL side, these are different tools technologies used. In the ETL side, there's a different ELT, there's a different tools. So let's suppose in the ATL side, there's a lot of tools like cloud side. When you move, there's Glue and the other tools you can use, the EMR, the Lambda, and other tools you can use. In the open source, there's a tool as well, like the Spark, like the DuckDB, like other processing tools you can use in the ATL side. So in the ELT side, sorry, and there's a DBT as well. So it's totally depend on your use case. What actually your use case, what kind of you are trying to accomplish from your problem statement. Let's suppose you want to build your just a data warehouse. Let's suppose I give you the example. Let's suppose I want to build a data warehouse. All the data that is coming from the source is a relational data, right? And data is not too much. The daily data is coming, 1 GB data is coming, and I want to develop the data warehouse that I can slice and dice the data, that can deep dive into the data, and can multi-dimensional data I can log. So in this case, you are developing a data warehouse. You check, okay, our source is not too much. That is the relational. So it's a simple system. So you can directly use the ELT systems that can first you load the relational data sources data to your data warehouse, then you do the data modeling or data transformation script, and you can easily complete the task. So that's a simple example. So it's totally depend on your use case. You cannot say like these are the best and this is not best.
Sure, thanks.
Okay, thank you. Let's move forward. These are all the tools like the Airflow and Informatica, the DBT, and these are the industry standard tools that are lot of industry that are following, that are working in these directions, and it's a great tool. These are the open source tool, the Airflow, the DBT, and all these things. So okay, let's move forward. So now we are basically move on the AWS cloud side. So on the cloud side, there's a lot of services. The big services they are providing, like you can say the cataloging side and searching side. There's a DynamoDB, there's Elasticsearch, the Glue, and the Amazon Kindra. So that's basically using for the cataloging, searching, and there's a other services like the analytics and the serving side. The Athena is there. There's the EMR, the Glue, the Redshift, and a lot of other services are there. So these are the a lot of big services. So we focusing on 2 or 3 services that are fulfill your 80 to 90% your use case in that services focusing. And a lot of other services, the manage and securing sides, that's not related to the data engineering, but when you're talking about the AWS, so you must be know of these services. So IMA services for your managing role and access, for the KMS for your security things, and the Cloud Trail for manage your all the logging things, and the storage side, there's storage gateway, uh, the data ingestion side, there's a storage gateway, the migration services, the direct connect and and so on. So, okay, these are the same thing. We're basically looking on the AWS side. So these are the simple the data pipelines. First of all, you have the data sources, you have the ingestion layers, then there's a governance layer, the data integration layers, and then data preparation layers, and then sorry, data pre-processing layer, then data processing layer. So these are simple data pipeline um, to give you the high level overview, and then basically the data is moved to the end users. All these stages when passed, so then data is moved to the end user. So sometimes it's not necessary to like build the data governance first. These these all are basically the downstream process. Like you first start with the data ingestion, then you basically the data integrations, then data pre-processing, then data processing, then basically the end user things are come. So let's let's move on the AWS side. I quickly move on this side. We have a lot of services that is using in the data engineering side, but there is a one services that name is the AWS Glue, that we basically the unified system that basically let me open the AWS Glue. I hope my screen visible, well visible to all of you, right?
Yes, 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 it is
Okay.
visible.
Okay, so this is the AWS Glue. So AWS Glue is basically the serverless data integration, the exact transform load tool that basically follow the 90% of your work can easily done in the data engineering part using this tool. When there's a complex problem statement comes, so at this stage you have to integrate this tool with the other AWS services. So but at this stage, to understanding give you the idea and give you all the end-to-end pipelines, end-to-end overview, so this is a best tool. So it's the Glue is basically the fully managed the serverless data integration services. So which will make the easy discover, prepare, and transform and combine data for the analytics, the machine learning as well, and the application development. So the key feature of this tool is basically the serverless ETL, like you're not going to manage the resources. So basically you can write the glue job the different programming language like the Python, different Scala as well, using the Spark. And there's a other like when you're building the pipeline, so there's a different things they are providing, like how you basically create the job. There's the visualizations, there's a notebook and all this stuff. Let's deep dive into it. First of all, when you go to the ETL side in the Glue, this is the Glue look, first look, the ETL jobs. So it's basically giving you the three different way to create your notebook, right? To write your code or write your pipelines or write your flow, all these things, right? So first of all, the visuals ETL. In the visuals ETL, it's basically you drag drop the things, you select the things, you end-to-end pipelines it create from that features if the things are simple or not complex. So other is the notebook side, and the third is the script editor. So notebook is basically giving you like a Jupyter notebook. Like at the right away you can show your result. You can see, okay, this data is coming, this is filtering fine, this is not, right? Let's explore the visuals ETL first, right? So in the visuals ETLs, there's a source system, there's a transform system, there's a target system, right? So the source, that is basically your data is coming. There's a transformations. A lot of most commonly used transformations are already there. You can just drag and drop and use these transformations. And the targeting is basically at the end you're writing the data to any of your target system. Either it's a database, is a warehouse, either it's a S3 storage or any kind of system. A lot of most commonly used system are already there, so you can just go and use there. So let's suppose we built a small ETL pipeline. So let's suppose we use the S3, right? We use the S3, and in the S3 side, so basically this is source, right? So you can give the any kind of the source system. Let's suppose I give um uh, so- okay, let's suppose I give the this is my source data, right? So let me check the, so you have to know your data. Like I just provide the S3, so you must provide the what kind of data inside this S3. So when I give the this healthcare, so this is a CSV file, right? So I go there, I select the data format is a CSV, right? And the comma separated, and first line contain the header and so on, right? So okay, so then basically you go there, add node. The second is the transformations, right? Let's suppose I want to see the data, right? So there is a query there. There is a SQL query transformation. Let's suppose I only know the SQL query, right? So here this is the SQL query. Select static from my data source. So you can select the your specific column, and you can do anything around it in the SQL environment, right? This is the transformations, the SQL transformations. So I'm using these SQL transformations. It may take few minutes to read the data. So then basically I use another node to the target. So let's suppose my target is in the S3, but in the different bucket and different kind of like a data type, the file type. Sorry. Let's suppose I choose here. This is a visual glue environment, right? So I choose the different. Let's suppose I choose this bucket. Okay, this is empty, fine. So I choose this bucket, the jar, right, and choose it, and I choose the file format. Let's suppose this is a Parquet file, right? I want to write the data in the Parquet file, and this is a compression type, the snappy. So just give you the high level overview. The Parquet is the kind of the file type that is a highly compressed file format. Let's suppose in the CSV file, that is in the 10 GB file. So when it's moved on the Parquet file, so it will be reduced the size. It's 10 to 2 or 3 or 5 GB around it, right? So it's a compressed the thing. So and I just name the things like test ETL job. Okay, so here this is my query, this is my transformations, right? So it's a column ID. All these are the column ID, right? So let's suppose I give the transformations here. So only give the cell number. Let's suppose I only give the cell number this. where cell number is equal to this, right? Hmm. Now the column parameter cell number could not result determine the following list cell. Okay, cell number. Just hold on. First line they contain the header. Okay, the cell number. Okay, let's suppose give on the ID. ID is equal to 101, where ID is equal to 101. I column function. Okay, the comma separated. Actually, this is not the comma separated. So it's something else. That's why it's only like lie in the one column. So we have to do some more thing. So just hold on the source. Let's suppose I give the pipe separated, not tab separated. Okay, so our data is the tab separated. Now it's create a proper columns and all this stuff. Now you can go here and you can where at the where conditions where the cell the ID is equal to let's suppose 2. So it's only select the specific data, right? So this is the data is selected. So just tell me, are you understanding the stuff or you all are like सारे खामोश हैं तो just give me go ahead like you are understanding the things so then I can move forward. Hello.
यस सर आ रही है समझ
समझ आ रही है आप लोगों को? हेलो.
यस सर समझ आ रही है
अच्छा अच्छा ये एक simple transform this is only this is simple transformation, so we save the stuff, right? So what we do, we only basically get the data and transform only ID is equal to 2, right? So now the job is safe. It's saving the data somewhere in the different directory, right? So this my job is the simple ETL job is created, right? So when I go to the run, so I just go there and just run the job. Before going into it, you basically go to the job detail and you select the number of workers and all this stuff. So it's as per your requirement, right? So I just run the job. It's basically do the processing and write the data to my destination. The job is running. It gives me the status like the number of retry, the start time, duration, and number of DPUs. DPUs is the capacity data processing units, right? In a single DPU, basically we have this type. This is a worker type. In the one worker is a 4 CPUs and 16 GBs of RAM, right? So when you have the number of worker 2, so it means the number of DPUs is 2, right? When you increase the number of DPU, it means you are increasing the number of systems capacity. So now this job is running. So we basically wait for its completion, move forward to the next thing. This is the other notebook stuff. The notebook, when you initiate the notebook, so basically it's like a Jupyter notebook, right? It's initiate the Jupyter notebook, the same thing that you do in visuals, so you can easily do in the Jupyter side as well, right? So in the Jupyter side, it's the same thing like you work in the Jupyter lab or in the Pythonic environment using the PySpark and all this thing. How many of you are aware of the Jupyter and Python environment or Python programming? Okay, this is a Jupyter, right? So same thing, it's providing a glue version, the version type, the number of worker. It's first include the glue related stuff, and here you are reading the data and writing the data and doing some transformations and then writing the data. So this is the glue, um, the notebook environment, right? So other than that, I move next. So in there is a script editor. So let's suppose you already have your written in the PySpark. So you just go there, upload your script or start from the scratch. So give you the skeleton of the job. You can write your job here, right? So here you can write any kind of job in the PySpark environment. Then you can save and give the settings, and then your job is ready, right? So other thing is there is a job run monitoring. So job run monitoring is basically tell you the total run in your date range, the job which is running, the cancel job, all the monitoring of your jobs is basically providing you the detailed overview, the high level overview of these. Sorry, high level overview, not the detailed one. When you go click and view job detail, so this is a detailed overview, right? So moving back, there is a data cataloging things are there. In the cataloging, it's basically have the different tables and databases. It provide you the information, the metadata of your data, right? So this is a different mechanisms. It's more detailed things. What actually the cataloging and all this stuff. So let's suppose you want the different S3 have the different data it contain. So each S3 location, let's suppose you have built some tables on top of it. So there's a database there, there's a table name in there. So let's suppose this location belong to this database and this name. It's tell what actually the file type there and what are the column type are there, and all these informations are basically handling by the data catalog in the glue environment. So moving forward, it's there is a data connectors are there. So let's suppose it's providing you more than I think 70 plus data connectors they are providing. So in the glue environment side, so let's suppose you can create your custom connectors as well. There is a connector type, the JDBC Spark, Athena, and some the marketplace connector as well as the create custom connectors are there, or these things are managed by here. Let's suppose the source system data is coming from the different system. Let's suppose the Redshift or some other services that connectors are you not available. Then you have to create your own connector, or some connector are available in the marketplace. You can choose the connector from the marketplace as well. So Other than that, in the data connections, there is a workflow are there. So the workflow is basically creating the workflow of your jobs. Let's suppose you create the workflow, you want to run first job and then second job. After completion of successful completion of the first, you have to run the second job and then the third job. So such a workflow you basically add it here. So let's suppose there is a test workflow. We give the name, and inside that workflow, you decide add a trigger here. Let's suppose there is a add new. Let's suppose the test. There is a test trigger, or it's basically schedule. Let's suppose the daily at this time. Test underscore daily add. So this is a trigger, right? So at this time, uh, this is a time. So it's run the job at daily at this time, right? So now you add the node here. Let's suppose I want to run this job first. I add this job. Let's suppose I want to add another job on the basis of its completion. Let's suppose I add an other trigger run second job. It's the event base, right? Um, After all, I add it here. So on the basis of this successful run, let's suppose I add it here another job, add, this is job is added. So on the basis of the this successful job when it's completed, so the next trigger to run this job, right? So this is kind of the workflow, the simple workflow. Let's suppose it depend on the first job, then second job, then third job, right? This is kind of the workflow that the AWS is providing the workflow. So other than that, there is the same thing, the databases. This is a metadata and the tables of this, and the schemas. Let's suppose you want to create a specific schema or different versioning of your schemas, so you can create it here. So there is an other techniques, the crawler. So what actually the crawler is basically creating the metadata table. It's crawl your data, identify the columns, identify the rows, identify the data type. So schema evolution strategy can easily be managed here. This is a crawler stuff, right? So, and I think most of the things are related to this. There's a detail concept, the security configurations and the sensitive data detections, then classification things. I think this is not, if we deep dive into it, so it's more detailed and things. So this is a simple job that we created here, the simple ETL job. So you can go here. This is a free services, somehow the AWS Glue, the some part, not all the things. So you can explore the things around it, and you can play the things or all this stuff. So other than that, there's another services that is basically the step functions. I quickly go through these services, not in detail. The step functions basically when you are creating the glue job, all the things that belongs to processing or ETL, that is inside the glue, right? So when you have, let's suppose you have the complex workflow, or you have the complex environment, or like um, a lot of other services you want to integrate. Let's suppose whenever the job fail, you want to integrate the notifications, when you have to monitor the things and trigger the things on time, a lot of things. So then there's a complex workflow can easily be managed by the step functions. Let's suppose I open one of the step function. Let's suppose I go there in the edit. So this is kind of a complex workflow. What it do, it basically start the ATL process. It invoke the ATL step function. It basically invoking the step function that basically passing here. It's it provide you have to provide the list of the step function. Here is basically merging the success cases and merging the failure cases. When all the list is completed, then it's moved to the next step. If there is a failure, if there any failure checker there, it's generate the essence notifications and then move to the failed state. If there is no failure, then basically its success is passed. So such a complex in machines you can easily create it here. These are the state machines. So this is step functions. So other than that, there is another services, the Athena services. So this is basically you can analyze any kind of data on a top of your raw data that is in the S3, that is in the glue catalog or anywhere in the S3, any.
एक्सक्यूज मी सर
जी जी.
सर ये स्टेप फंक्शन के बारे में दोबारा बता दें अगर थोड़ी डिटेल वगैरह
Uh,
थोड़ी सी
did you guys read the state machines? What are the state machines in one of their subject? I think I don't know the name. There's in the CS catalog. There's where you basically study the state machines, different state machines, the success and the fail and all these things. You aware of these? Hello.
हुज़ैफ़ा सर हमने एक बार सुना था फाइनाइट स्टेट मशीन और इनफाइनाइट कुछ इस तरह हमने पढ़ा था.
Yes, exactly. These are the state machines. Basically, the state machines are, let me open first. So, the step function is like a state machines, like where you are creating the complex workflows. Let's suppose sometime a workflow comes where this is not a simple ETL. You have to wait for first part to complete and then you basically add some other services that basically verify some data and then give you the go ahead, right? So such a complex state machines you can build in the step function. So in the state machine, let's suppose this is a simple state machine. What it do, so it basically run the glue job, right? So and wait for its completion. When the job is succeeded, so it's like go there and delete old file. And when job is failed, so it's go there and give error. It's let's suppose this I have the test job here. Let's suppose inside here give execution. I go the execution. Let's suppose I just copy this. Okay. So the complex workflow, any kind of workflow that is basically you can integrate any kind of other services of the AWS glue, sorry, AWS, you can create that workflow here. So you see here, this is the all the actions, all the other services are in the left pan. So let's suppose most of the time your ETL workflow, it's not so simple. It's calling a lot of Lambda functions, a lot of other services is just invoking, a lot of other tools that are using in your pipeline. So for developing such a workflow, such a complex workflow, basically you use the step function for this. You understand the idea? Hello.
Yes, sir. Yes, sir. आगे sir.
Okay, so these are the basically these are the step functions. So to developing the complex workflow in your AWS environment, right? So a lot of other things you can do, but mostly it's for the workflow automations, the orchestrations. We use the step function. This is a high level overview of this. So a lot of any kind of AWS services you can integrate with it. Let's suppose there is a inside the database, when the specific record come and you have to trigger the glue job, and then after the successful of that glue job you have to trigger the lambda function, and then when the lambda function is fail or pass you have to send the notification. So it's sort of the complex workflow, right? So the different state is the data is flowing. So such a workflow cannot be done in the AWS Glue environment. You have to use the step function. So this is a simplest overview of this. Okay, moving forward, there's another services. The name is the Athena, right? So Athena is basically, let me open this. It's basically serverless interactive queuing for data lake analytics, right? So it's basically pay as you go services. It's per sorry pay per query. It's when you run the query. Let's suppose I run a different query here. This is a query. This is my data that is in the S3, right? So when I run this query, it's telling the 686 MB is data is scanned. So I only pay the payment of data I scanned, right? So for 1 TB, I think it's cost for $5. So this is like you can say based on the standard SQL, any kind of query you can write it here on the top of table, your table. This table is basically holding the data that is in the S3 in your data lake, right? So this is serverless SQL interfaces giving like broad format support it's providing, right? And schema on read, when it's reading the things, it's build the data schema on the top of it. So that's the Athena. Here you have the data sources, then your catalog, then your databases here. A lot of databases are here. Let's suppose if I choose this, inside this I have no tables. Let's suppose I choose this, I have one table, the dynamo from Kinesis. So when I query the preview table, it's give the select static from this, so and show the data, right? So this is the data, it's a table format. So this is the Athena. Any ad hoc analysis, the common use case is ad hoc querying on the top of your S3, or quick data explorations on top of your data, or validations on top of your data. We use the Athena. Or it's also providing you the dashboard on the top of it. You can connect any kind of dashboard BI tool with this as well. So mostly we also using the Athena for the log on event analysis as well. So that's Athena services, right? And it's a SQL based environment, the table based environment. You can download the result as well. You can reuse the query result as well. So, and query stats you can look at here. So a lot of things you can create your own table on top of your data, or the create tables. Here is the create table from S3 data. Let's suppose you give the table name, you provide the database, and then your S3 source are here. Then data type, it's a JSON or any kind of data format. You can choose it here, the CSV, TSV, JSON, ORC, the Avro, and any kind of format, file format you can choose, and then you can create your table here. So it's treating you a table in the database, right? This is the Athena. When you more into detail, it's also providing you the PySpark and Spark SQL as well. So it's give you the notebook, right? So the notebook that you can easily do the more Spark based job using the Athena, right? So this is Athena services. You can create a notebook here. That's the Spark, the table format. It's more detailed topic what actually the table format are there. It's an open table format. You can go and read from the web. So, and you can create the notebook from this. So I already have the default notebook. Let me show you. Yeah, I think this is a simple hello world, and you can use the SQL environment. This is a Jupyter notebook, right? In the Athena environment. Terminate the session. Okay, let's move forward. We have another services that is the Lambda, right? So Lambda is most famous services, the AWS services. So Lambda is used, it's kind of the small code, any kind of your code that you can run on the server that doing any kind of task that's not more than 15 minutes. For such a purposes, we use the Lambda functions. So when you move into it, so it's providing the different programming environment, right? The Python, the Node, the Java, and .NET, and a lot of others as well, right? So you can write the code it here, and you can, let's suppose, when give me the example. Let's suppose in my ETL, whenever the 10,000 record is aggregated, or whenever, let's suppose, when the end of the month, I want to aggregate the data, or I want to run the aggregation job. Let's suppose at the end of the month I want to run the aggregation job. So for these purposes, I have to trigger. Let's suppose this trigger can easily be done in the Lambda environment as well, can easily be done on the AWS Glue side as well. So let's suppose in my Glue job, I have the,
Zephyr sir, I have a question.
yes,
Sorry for
go ahead.
disturbing in between the session. Uh, ये जो होती है हमारे पास एक lambda और एक EC2 instance ना, both are doing the job of computing. तो जो हमारे पास AWS lambda है, क्या ये इसके बैक पे जो सर्वर्स है वो EC2 के ही हैं या इसका टोटली अलग सेटअप होगा?
नहीं, ये हमारे पास सर्वरलेस होता है. इट्स अ सर्वरलेस,
वो तो
राइट?
चले
इट हैज
सर्वरलेस है ना, हमें मैनेज
सम
नहीं करना पड़ता
लिमिटेशंस.
कॉन्फ़िगरेशन वगैरह ना,
एग्जैक्टली. देखिए
लेकिन
हमारे
इसके
पास
बैक
कोई भी इस पे बैक पे ना इन्वायरमेंट आपको सेट करके देते हैं पाइथन इन्वायरमेंट का. let me give you. There is a configurations there. Uh, in here, general trigger permissions. Okay. Permission is not here. Okay. So it basically here ये आपको सेट करके देते हैं environment. वो इन्वायरमेंट क्या होता है? वो होता है रन टाइम इन्वायरमेंट एनी प्रोग्रामिंग लैंग्वेज का जो आप सिलेक्ट करते हैं। इसकी बैक पे जो आर्किटेक्चर होता है वो x86 64 ही होता है, ठीक है ना। तो ये बेसिकली होती आपकी EC2 मशीन ही है, इन्होंने इंफॉर्मेशन यहाँ दी हुई है। lambda functions is the type of the compute processor that a lambda use for the function। x64 is choosing दी हुई है। देखें इसमें ना आप सिर्फ और सिर्फ आपके पास जो परमिशंस होती है ना वो होती हैं कि आपने इसमें से मेमोरी कितनी आपने यूज़ करनी है। मेमोरी की सिलेक्शन की वो आपको देते हैं। यहाँ पे जाके आप जो है ना मेमोरी 128 MB है ना, इसको आप अपनी मर्जी से सेट कर सकते हैं। एक लिमिट होती है 10240, लाइक 10 GB तक आप इसको दे सकते हैं, ठीक है।
ओके,
और इसमें
थैंक यू।
ये एक स्टोरेज होती है, ये भी आप 10 GB तक जो है ना ये दे सकते हैं, या आप इसके बारे में पढ़ें तो आपको बता देगा। मोर कंप्यूटेशन टास्क के लिए आप जो है ना ये यूज़ कर सकते हैं। और यही सिर्फ सेटिंग होती है, इसमें टाइम आउट की सेटिंग होती है कि ये आपको मैक्स जो है ना 15 मिनट तक देता है। सॉरी ये है ना, ये देखें ये आपको मैक्स 15 मिनट तक देता है। उसके अलावा आप इसमें कोई चीज़ मैनेज नहीं कर सकते। सर्वर साइड की आपको एक्सेस नहीं होती, ये किस पे चला रहे हैं बस उसकी आपको इन्फॉर्मेशन इन्होंने यहाँ दे दी है। इसके अलावा EC2 एक डिफरेंट थिंग है। EC2 एक लाइक अ वर्चुअल एनवायरनमेंट विच दे प्रोवाइड यू एज अ मशीन फुल एक्सेस। वहाँ आप कोई भी प्रोग्रामिंग लैंग्वेज करें, वहाँ पे आप कुछ भी करें, इट्स अप टू यू, 100% एक्सेस। वो जब तक वो चल रहा होगा, वो अप एंड रनिंग होगा, उसकी कॉस्ट पड़ेगी। यहाँ पे ये आपने लैम्डा फंक्शन बना दिया, जब ये लैम्डा फंक्शन ट्रिगर होगा तब इसकी कॉस्ट पड़ेगी। वैसे ये फ्री पड़ा है, पे एज यू गो है, ये आपको कॉस्ट नहीं कर रहा होगा जब तक कि आप इसको यूज नहीं करेंगे। तो लेट्स सपोज मेरे पास दिन में लैम्डा फंक्शन है, वो दिन में 10 दफ़ा यूज होता है और वो 1 मिनट चलता है। तो 10 दफ़ा यूज हो मतलब कि 10 मिनट मेरी कॉस्ट पड़ेगी, और बाकी के जो जितने भी टाइम होगा इट्स फ्री, इट्स नॉट कॉस्टिंग अस। So that's why we use on the lambda side, lambda function side.
थैंक यू
So
हुज़ैफा। एक क्वेश्चन और भी था
this
लेकिन अब
is
टाइम बहुत कम है
जी
हमारे
बताएं
पास, तो खैर है अब
बताएं
चलते
बताएं
हैं
आप।
अभी। अच्छा, उस दिन में इंटीग्रेट किया था मैंने AWS लैम्डा Amazon API के साथ ना, API गेटवे के साथ।
हम्म
तो वहाँ पे बार बार मेरे फंक्शन में ये इशू आ रहा था कि हालांकि ये जो 18 पॉइंट नोड जेएस 18 वेरिएंट तक जो है ना, ये सपोर्ट करता है इसे, सॉरी हाँ, नोड जेएस जो 18 वेरिएंट तक है ना, ये सिर्फ सपोर्ट करता है आपकी जेएस फाइल को ना। लेकिन वहां पे बार बार वो MJS से सेव हुआ हुआ था और पता नहीं बैक एंड पे उसके क्या इशू आ रहा था। ऊपर चैट जीपीटी से कोड मैंने सारा सेट करवाया था।
अच्छा, इसमें ना lambda में ना एक ऑप्शन होती है, जब आप क्रिएट lambda करते हैं ना, तो एक होती है कंटेनर इमेज की ना। कंटेनर इमेज ये होता है कि आपने वो सारा का सारा अपने सिस्टम पे डेवलप किया, उसको बताया कि मैंने ये चीज़ें इंस्टॉल करनी है, वो फिर आप एज अ कंटेनर इमेज डिप्लॉय करते हो, एज अ लैम्डा फंक्शन रन हो रहा होता है। तो उसमें जो इन्वायरमेंट सेटिंग होती है ना, कि आपने नोड जेएस जो इंस्टॉल किया है ना, वो आप अपनी मर्जी का करेंगे। और जो आपने रिक्वायरमेंट डॉट टेक्स्ट फाइल के जितनी भी रिक्वायरमेंट है वो आपकी मर्जी की होंगी। तो ये एक होता है जब इस तरह के इन्वायरमेंट हो ना कम्प्लेक्स, के आपका इशू आ रहा हो विद उसकी क्या कहते हैं वर्जन्स का, और उसकी डिफरेंट लाइब्रेरीज के साथ, तब आप मूव टू द कंटेनर इमेज। आप इसके बारे में पढ़िएगा, और ये एक बहुत ईजीएस्ट वे और बहुत ही ज़बरदस्त वे है कि आप कंटेनर इमेज डिप्लॉय करें। और वो एज अ उसके अंदर आप सारा लैम्डा फंक्शंस का एक वे होता है वो आप बताएंगे और वो एज अ ट्रीट करेगा लैम्डा फंक्शन की तरह।
ओके ओके, थैंक यू।
वैसे आप उसे थोड़ा सा R&D कर लें, हो सकता है उसके अंदर अवेलेबल हों ये चीज़ें, देखना पड़ेगा। अच्छा, मूविंग फॉरवर्ड हमारे पास ना एक डाटा इंजीनियरिंग में जो एक बहुत ही द मेजर thing is the AWS. AWS is basically the, you can say it's a data warehouse on a cloud, right? So it's a fully managed petabyte scale data warehouse service in the cloud. You can run the complex analytical queries across the large volume on the AWS side, or it's handle the structured and semi-structured data, or you can run the query in the SQL environment. So ये हमारे पास Redshift का सेम एज डेटाबेस पोस्टग्रेस की तरह का एनवायरनमेंट होता है, जिसके अंदर हमारे पास ये एक स्कीमा बना हुआ है। इस स्कीमा के अंदर जब हम जाते हैं तो हमें डिफरेंट, ये डेटाबेस बना हुआ है, डेटाबेस के अंदर डिफरेंट स्कीमा होंगे। यहाँ पे डिफरेंट स्कीमा ऑपरेशंस, पब्लिक, रॉ डाटा एंड डिफरेंट इन इनसाइड दिस स्कीमा वी हैव द डिफरेंट टेबल्स। सो यहाँ पे हमारे पास कोई टेबल नहीं है, यहाँ पे हमारे पास टेबल है, हम यहाँ पे देख सकते हैं। लेट्स सपोज ये हमारे पास एक टेबल है, सिलेक्ट टेबल, ये हमने सिलेक्ट किया है, इसको हम रन करते हैं तो ये हमें टेबल का शो कर देता है। तो ये एक डेटा वेयर हाउस है। डेटा वेयर हाउस एक एक इट्स लाइक अ सेम relational database, but it's have the capacity to process the large volume of the data, millions of billions of record को easily manage करता है। अगर डीप डाइव करेंगे तो इसमें आपको बहुत सारी चीज़ें और मिलेंगी। You can schedule the queries in here as well. Let's suppose in there's a questions come the ELT side. Let's suppose the ELT, when you are building the ELT, you load all the data in the data warehouse. So then you have the query to process the data, to clean the data. So then you have to schedule the query. Let's suppose daily 12 p.m. पे मेरे पास डाटा आ जाता है, so then after that I schedule the query to verify the data first, then process the data and move the data to the different stages. So this is data warehouse ecosystem of the uh, AWS environment. So this it is using inside the industry. A lot of big industries, the big companies are using it. So the same thing, it's you can integrate any kind of PI tool, any kind of integration system you can integrate. So this is the data warehouse. A lot of other services are also there, but these are the main focusing area of data engineering using AWS. So if you guys have any questions, so then you can ask. So now we are wrapping up here. So yeah.
अगर किसी के कोई क्वेश्चन भी है तो वो भी कर लें, वरना एटलीस्ट रिएक्ट कर दें, ठीक है।
जी,
सयाम अब्बासी, सारे मुबासी सोए। सारे
okay team.
मुबासी।
If you don't have any questions, then we can wrap it here.
सारे आपकी आवाज नहीं आ रही। आई थिंक क्वेश्चन नहीं है, सारी माइक ऑन है लेकिन आवाज नहीं आ रही। Okay, Sir Huzefa, thank you so much for giving
Okay.
wonderful insights in today's session. And
Okay.
inshallah हम
Thank
लोग
you.
आगे events में आपसे मिलते रहेंगे. Thank you so much
All
for
right.
joining.
Thank you. Thank you.
Thank you. Assalamu alaikum. Thank you everyone for joining today.